A Ramdisk is a temporary booted live OS which performs a task while running purely in memory. And we see this very often, for example, on iOS, watchOS, bridgeOS, when we boot a Ramdisk for a restore or an update. So every time we do a firmware update, a Ramdisk is loaded. This happens in certain steps. So if we restore or update over a MacBook or PC, we always load the iPSW, the iBack, the device tree, the Ramdisk, the trust cache, and the kernel cache. And all of this is protected and signed using cryptographic hash of the Apple server, which is also known as SHSH blob. So only verified, non-modified iPSW, iBack, device tree, Ramdisk, trust cache, or kernel cache can be loaded onto the device. And if this is not the case, then the device will reject this. In case of our SSH Ramdisk, we use the checkmate exploit, which will make it possible that we can load another iPSW, an arbitrary iPSW, onto the device. The same goes for all the other boot chain, and we are no longer forced to use a signature by Apple, but we can just load arbitrary boot chain. So we need a few components, which are the patched iPSW, the patched iBack, the device tree, the Ramdisk, of course. We need to infuse the SSH into it, and an arbitrary trust cache, and of course the patched kernel cache, and the SHSH, which will fake sign our boot chain. Here it doesn't really matter which pile it is. It can be an arbitrary SHSH. Only the device model is important, so make sure that you get an SHSH blob for an actual T2 Mac. And you probably wonder, why do we need this? There are some use cases. First is the data extraction. We can extract account information, so the email address or the Apple ID and surname and last name of the user. We can mount the internal SSD as external storage, so we can extract user data in case we know passwords and the disk is not encrypted and locked. Unlocking and bypassing is also possible. For example, if he unlocks, we can do firmware password removals, we can do untethered iCloud bypasses with the Gestalt method, but we won't talk about this in this episode. There is maybe another video where I will explain how this exploit is working. Right, so first of all, we need to download the boot chain for our device. In our case, it's the Marvel J214K. So we select the iBack and download it with partitialZipBrowser, and we also do this for the device tree. And we also need the trust cache and the Ramdisk. So probably this file, yes. And so far we still need the Ramdisk. This is this file, always the biggest one, and it takes a few seconds. And then we can already start creating our boot chain. First we take the device tree, and there we don't need to do so much. We just need to change the tag from DTRE to RDTR, so it's the restore device tree and not the normal device tree. This is later important for the booting process. So we need to resize our Ramdisk and created with the bundle which you can find in the downloads, and yeah, just add it to the decrypted Ramdisk, and yeah, then we will just also create the image 4 of it, and yeah, that's it basically for this step. Then we also need the trust cache, of course, and yeah, that's it. So now we are going to patch the kernel. So first we are going to search for the string internal error no cd hash found. Yeah, there's just one entry actually, so just click on it and follow the data xref, and yeah, then follow the next code xref of this where the string is actually called. And then you will find two move instructions, and you select the BL instructions below the second one, and yeah, just follow. This now should be the lookup in static trust cache function, and yeah, that's basically the function which we need to patch. So yeah, you go to the beginning, and then you can open the hex editor and yeah, change the bytes here. So we edit and we enter them, and then we save it, and then our function should always return 1 as value, and that's it so far. So yeah, we are going to patch it now externally, because in EDR Pro we always have some issues and it will just fuck up our whole kernel cache. So yeah, just select this offset here, and yeah, go to Finder and open the kernel cache in hex find, and then Command L is, I think, the offset, yeah, and then you just print the offset there, put it there, and then it will jump to the correct location, yes, and then yeah, replace the bytes there. Again, you can see the bytes here, and just enter them there, and alright, so that's it basically for the patching. Now we just need to save it, and then we need to compress the kernel cache into the image 4 format and sign it, of course. So yeah, here we compress it, and then we create the finished kernel cache as image 4, of course with our signature, yes. Alright, and that's it so far. Now we also have to patch the iBSS and IBAC. So yeah, we're doing this by decrypting it first with the guest exploit. It will, yeah, decrypt it automatically, so we can find the ibac.raw, and yeah, we will duplicate this file now and make it iBSS, because the file is basically the same. So yeah, we patch it, sign checks. We do this also for the IBAC. And yeah, now we have to check the IBAC for the boot args, which yeah, we set to serial 3, which will give us serial output, and verbose mode and watchdog -1, so the device is not turning off after 10 minutes. So yeah, we create the image 4s now of the iBSS and also the IBAC then. So yeah, the iBSS, image 4, sign it, and that's it. And the same for the IBAC now. First the EM4P and now the image 4. And yeah, that's it so far, and now we can already start booting it. So we run the gust exploit, and now we need to connect our Mac in DFU mode. And yeah, this worked, and now we send the iPSW twice because this we need to root. And yeah, we upload the device tree and the Ramdisk and the trust cache and our kernel cache, and then the device should boot up and we can get SSH. Yes, perfect. And yeah, we can mount our disks, and then yeah, currently we are on bridgeOS 10 beta version, which is technically the macOS 26, which was released as developer beta. And yeah, we activated this device here, so yeah, it's activated. But about the bypassing we will talk about in another video. And if you like this episode, of course subscribe and like, and see you in the next one.